The team in Brussels was the subject of my next filming.
So, welcome to the chemistry department of the Université Libre de Bruxelles, University of Brussels. We have to find a way to deposit the nanoclusters, the metal nanoclusters on the carbon nanotubes using atmospheric plasma techniques. But a non-metal doesn't like to stick with a metal. If you want them to stick together, you need to create an interface, something which is intermediate. That's the reason why we need to activate the surface. Otherwise, these guys don't want to go together. So.
À présent, je réduis la distance entre la torche.
What kind of experiments will you be doing?
You asked me what kind of experiments we will do. Well, at least at the beginning of the project. Just imagine that this is the nanotube, and we have ultimately this is the carbon nanotube, and we have to deposit on this carbon nanotube very small metal particles, which is in the nanometer range. The group of Jean-Jacques Pirot in Namur can do that using vacuum techniques. And it works quite well, I must say. You have seen maybe fantastic pictures of that. And the idea is to use this plasma to deposit the particles, but in air, atmospheric plasma. So, just to summarize again, we will start not using substrates as like nanotubes because it's too complicated to manipulate at the beginning. So we'll use HOPG. So HOPG is a highly oriented periodic graphite. So it is the same element as a nanotube. It's carbon. And it has basically the same kind of structure of a nanotube, but the advantage is that it's flat. It's completely flat. I should even say it is atomically flat. Then we will use a plasma system. In this torch, we will generate, I should say, ions, with electrons and neutrals, plus, minus, and n. They will be sent out of the torch. Okay, and the gas that will be used is either argon, helium. The first step will be what we call an activation of the surface. So we hope that we will put on the surface active groups that can be oxygen or nitrogen containing groups. So in that way the surface will be activated. That does mean that the surface will be ready to make a chemical bond with the particles that will reach the surface. Also, we will create small holes in the surface. Strange, the idea that one wants to create defects on the surface. Well, if you have a defect, you increase the reactivity of a surface. So this is the goal that we need to reach. First on graphite.
Is there a possibility that some new science may come out of this?
Okay, as I just mentioned when I was explaining the plasma, heat is the worst way to activate a chemical reaction. Plasma chemistry is a chemistry of the 21st century. So the chemistry of plasma is still at the very beginning. The chemistry in the gas phase is very, very complicated to understand, and it's still the beginning of this new chemistry. So this is, I think, the new science that we can bring there. The nano part of this project is also a way to bring new science. We have fantastic new properties of metals at the nanometer scale. Just to give you a very brutal example, gold, for instance, gold is known to be a non-reactive metal. This is why it is such a valuable metal. People like to have gold because gold doesn't corrode, gold stays forever, So gold basically has no chemical interest. It doesn't react. But when you decrease the size of gold, when you go to the nano size, then suddenly gold starts to have chemical reactivity. And then you create new chemistry again, because you just decrease the size. And that's fantastic. So this is the two parts of new science that we can bring.
Tell me about yourself. Tell me what kind of person you are.
This is a very private question. Speaking about myself, I'm 41 years old, and I've done quite a few things in my life. After my PhD, I went to the army. At that time in Belgium, we had to go to the army for 1 year. And then after that, I found a temporary position at the university. I like paintings. I like, I do some sports. I have the chance to live very close to the forest, so I do a lot of jogging when there is no storm like today. I have many problems indeed. I like nice cars also. I don't think I'm the typical scientist as people can imagine. I like life.